Ionic equilibrium in short discussion lecture 2. The rest are given in brief. Okay. Now we consider buffered solution. For many lab experiment, we have to perform some experiment about buffered solution. Okay. What are the buffered solution? The solution which resists the change in its pH value by addition of small amount of acid or a base is called buffer solution. Means the solution do not change their pH value if we add small amount of acid or base. By adding small amount of acid and base, the overall pH of the solution does not change. This solution are termed as buffer solution. Now we consider acidic buffer. Acidic buffer, you always remember for study amino acid, acidic amino acid always have the pH value less than 7. Okay, almost 3 to 5 value isoelectric point, right? Similarly, for acidic buffer, always pH less than 7 means they are acidic. 7 means always neutral. The solution is neutral, then give pH value 7. If greater than 7, the solution is definitely basic solution. If less than 7, the solution is definitely acidic solution. Okay. Acidic solution means pH less than 7. As per example, that should be made by acid and their salt. That is acetic acid and their salt, sodium acetate. Maybe reaction of NaOH and acetic acid, we get sodium acetate. Okay. Sodium acetate is nothing but is a salt of acetic acid. Okay. That is the combination of acid and their salt are called acidic buffer. As for example, boric acid and borax. Borax means Na2 before O7 dot XH2O. Okay. And boric acid H3BO3. Okay. Basic buffer when pH greater than 7. As we know, when the solution having pH value greater than 7 means the solution is definitely basic. Okay. And that should be made by base and their corresponding salt. NH4OH and their corresponding salt, that is NH4Cl. Maybe NH4OH and react with HCl, that is hydrochloric acid, it must be produced NH4Cl. Okay. In our buffer system in blood, we see that is H2CO3, that is carbonic acid and sodium bicarbonate. That is must be acidic buffer. Okay. H2CO3, sodium carbonate and sodium bicarbonate. Okay. Now we consider the simple value pH equal to pKa plus log of salt by acid if we consider acidic buffer or acidic solution. And when POH, that should be equal to pKb for base. pKb plus log of salt by base. Okay. Okay. And when we consider, always remember pH plus POH equal to 14. Okay. pH plus POH, that should be 14. So pH equal to 14 minus POH. Okay. As you always know, that is minus log of concentration of H plus equal to pH. So the value of concentration and their negative log we get value of pH. Similarly, POH we can determine, and by this way analyze. When we sum up their quantity, we get the value overall 14. And also you know that is Kw of water, that is neutral, that should be some x into 10 to the power 14 type value, right? From this type of value we can get the idea that neutral solution having pH plus POH, that is equal to 14. Okay. Okay. Always remember that should be greater than 7 means basic, less than 7 means acidic, and when almost equal to 7 means neutral. almost 7 means neutral. Okay, now we consider buffer capacity. That should be defined as number of moles of acid or base added in 1 liter solution to change for pH by unity. When pH, actually for buffer pH does not change by small addition of acid or base. But when after certain time by addition of acid or base, their changes can be seen, and that must be slow change. Okay. So when unity, change of pH by unity can be take place by addition of 1 liter addition of number of moles of acid or base in 1 liter solution is defined as buffer capacity. That is must be the number of moles of acid or base that should be capable to change 1 liter solution pH by unity. Okay. Now we consider buffer capacity. By mathematically we can say that is number of moles of acid and base added to 1 liter of buffer by changing pH. With respect to pH, number of moles of acid or bases that should be added to in 1 liter of buffer to change the pH are termed as buffer capacity. Okay, nothing but. Now we consider solubility product. Means what? Suppose AXBY is a general formula, that should be a compound. Okay, where XAY plus and YBX minus are there. Okay, so their solubility product that should be KSP. KSP is a solubility product equal to AY plus to the power X. X is the coefficient of AY plus. Y plus is the charge of A. So we get KSP equal to AY plus to the power X. Bx minus to the power y. Okay. Now we experimentally get this value. The first one, if ionic product is less than KSP, if their corresponding ionic product that should be less than overall KSP, no PPT or precipitation is formed. Okay. If ionic product that should be greater than KSP, the PPT that should be formed, and PPT that should be precipitate. Okay. And when they are same, reaction is in equilibrium. By this way, you can say the reaction will be equilibrium. Okay. So when we use in laboratory performance in M.Sc or Ph.D, we have to consider some inorganic elemental analysis. Okay. For group analysis, there should be many phenomena based on precipitation. So for a salt, their cation, anion, their solubility product, their ionic strength we have to measure. When their ionic product that should be greater than KSP, only on that condition PPT that should be formed. Otherwise, there is no chance for PPT formation. And if they are equal, that means they are equilibrium. Okay. Now this should be have to memorize, but not so important for NET GATE examination, for BARC examination. They are not so important. Even M.Sc they are rarely asked, but they are maybe come in HS, higher secondary. Sometimes it may come in B.Sc level, and you have to know actually for concept. Okay. So first one, for salt like AB, as for example in NaCl, there should be salt like AB. Okay, 1 cation, 1 anions ratio are there. Okay, so KSP equal to S square. Okay, S equal to root over KSP. So actually NaCl is not this type of salt. We actually think AgCl. Okay, they always show precipitation. There should be some equilibrium can be established. NaCl, there must be no chance for equilibrium, because NaCl is a strong electrolyte. It always dissociates in dissolved state into Na plus and Cl minus. There is no chance or no probability to find equilibrium. Okay. So for salt like AB equal to KSP equal to S square, solubility product, S square, S equal to root over KSP. Okay. S means I think solubility. Okay, solubility of each ion, and KSP is the solubility product. Okay, solubility constant we can say. Okay, Okay. For salt type AB2, AB2 means 1:2 ratio, cation anions are present. That is Ksp equal to 4s cube. There should be S equal to Ksp 4 whole 1 by 3. As we know, as Ksp equal to S cube, so S cube equal to what? That is Ksp by 4. And as it is root over 3, so we can say whole 1 by 3. Right? We can say by this way. Okay. Okay. Now we consider AB3, Ksp equal 27, S4. So by this way, same analogy we can say that is S4 equal to Ksp by 27, right? If we consider only if we detect S, then 4 will be this type. Okay, right? Okay, that should be given here. Okay. Now always remember, for 3 equation there should be, this is you can memorize, but this is not so much important. Okay. Okay. Now the difference between, or you can say that is the phenomena of solubility product and ionic product. Solubility product of ionic concentration in saturated solution, when there is maximum number of solute or maximum number of ions that should be present in solution, that is called saturated solution. Okay. So product of ionic concentration in saturated solution. Okay. If after addition of solute or after addition of ion, there must be maybe precipitation can be occur. That is called solubility product. That is product of ionic concentration in saturated solution. Okay. Saturated solution means the solution where if you add more solute, there will be no mixing of the solute, there should be definitely precipitation. Okay. Precipitation, or definitely they are still in the solution. Okay. After addition, they are not dissolved. Okay. An ionic product, ionic concentration in any type of concentration, there is no term, there is the saturated solution term is not mentioned in ionic product. Okay. Okay. That is the difference between solubility product and ionic product. Okay. Okay. Solubility product applicable only for saturated solution, which I mentioned, and ionic product applicable for any type of solution. There is no need to consider saturated solution. Now for pH metric acid base titration curve, some curves are given. For first one, strong acid versus strong base, as for example HCl versus NaOH. Suppose, okay, that is there should be in y-axis ml of acid, the amount of acid that should be given, and ml of base in x-axis, that is amount of base that should be given. Okay, there must be the curve, amount of base that should be increased in x direction, amount of acid that should be increased in y-axis. So when base that should be added, amount of acid that should be going to increase to neutralized. After a certain time, there should be neutralization can be there. Okay, so we have to use some indicator. As per, we can use phenolphthalein, we can use methyl red, we can use methyl orange also. They are act as acid base indicator. As they are due to structural change, they always show their different color in acid and base. Okay, due to this we can detect the solution having more acidic, or the solution is more basic. Okay, or the acidity is neutralized, or the basicity is neutralized. Okay. So first one, phenolphthalein, that should be pH 8.3, applicable only pH 8.3 to 10.5. Okay, applicable pH 8.3 to 10.5, almost basic media. Methyl red, that should be used pH 4.4 to 6.5. 4.4 to 6.5 mean that is acidic to neutral range. Acidic to neutral range. Okay. Methyl orange, pH 3.2 to 4.5. 3.2 to 4.5 means overall acidic range. Okay. Okay. Now we consider strong acid versus weak base. There should be ml of acid is y-axis, ml of base. There should be, when bases are still there, base in case they are in that maximum, strong acid are given, weak acid, strong acid are given, weak base, that should be neutralized. Okay. Methyl red, in that case methyl red, methyl orange are suitable because that should be more acidic bench. Okay, so here methyl red, methyl orange are suitable. So weak acid versus strong base, there should be ml of acid, there should be ml of base. So there should be ml of base and there should be ml of acid. So here weak acid neutralize this position. In that range, in that range phenolphthalein used. And weak acid versus weak base, there should be in that position iteration. There are no suitable indicator used. There should be used other type of indicator, other type of system.